Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh and hi. My name is Muhammad Hamshari Hamizan bin Muhammad Zaidi, and today my team and I wanna present the project assignment about Colpitt's oscillator circuit using MATLAB Simulink. Before that, let me introduce first our team members. First, me, Muhammad Hamshari. Next is Muhammad Fuadi. And next is Siti Munira. Next is Azrin Ikhwan. And last but not least is Daniel Izzuddin. Without further ado, let's go to the introduction. Okay, now is introduction. What is MATLAB Simulink? Simulink is integrated with MATLAB, allowing data to be easily transferred between the two programs. Simulink is also a MATLAB-based graphical programming environment for modeling, simulating, and analyzing multi-domain dynamical system. Simulink also is widely used in automatic control and digital signal processing for multi-domain simulation and model-based design. Simulink has a graphical user interface (GUI) for creating models in the form of block diagrams. So at my left part is one of the example Colpitt's oscillator circuit. So basically this project where we will build n Colpitt's oscillator circuit according to the instructions given by the lecturer using the Simulink. By employing positive feedback instead of input signal, an oscillator converts DC input signal into AC output waveform with a specific variable frequency drive and a specific shape of output waveform, such as sine wave or square wave.
For chapter 2, which is method, we have a procedure to follow. First, we need to open the MATLAB Simulink programming mode. After we open the MATLAB Simulink programming mode, we need to click on the Simulink taskbar. Next, we need to click a blank page that we can see through the figure, and then we can save the folder. For the folder name, we can put any name that we're comfortable with it. Then, for the number 5, click on the Simulink library browser to place the components according to figure 1. And number 6, incorporate the resistor, capacitor, inductor, DC voltage source, voltage sensor, and NPN bipolar transistor into the model. After the components have been installed, the wires must be connected. The solver configuration has also been updated. The output voltage is now displayed on the display. The PS Simulink converter was used to connect the voltage sensor to the scope. For the number 7, we need to click in the model settings, and then we set stop time for 0.02 seconds. And then we need to click run Simulink model to display graph results based on figure 1, or else we can click on the scope to produce the graph. And then we click the run icon so that the graph will display. And for the last questions, which is for the questions D, we need to get the new circuit and get lower voltage than in figure 1. We need to change the value of capacitor on the tank circuit to get the low voltage than figure 1.
This chapter about how the result simulation using the MATLAB. Firstly, build the circuit with value setup, the stop time 0.02, and for the Colpitt oscillator circuit for high frequency, we using 24 nanofarad and 2040 nanofarad for capacitor and 10 millihenry for inductor at 10 circuit. The output sine wave graph will appear as this simulation. Let's watch this video. 24 nanofarad and 2040 nanofarad and stop time 0.02, and double click. Then I running this simulation for the high frequency. This sine wave appear according to the value of capacitance. The large value of the capacitance, then the sine wave will also be wider as this simulation. For the low frequency, This circuit we change to 0.44 UF and 9.56 UF capacitor and same value for inductor. This value more high than value of the capacitor at high frequency. Then that is how the sine wave graph will simulate that according to the value of the capacitor or frequency. 0.44 UF, 9.56 UF, and change to stop time 0.02 and double click. This is simulation for low frequency. For the question A, what is the Calpe oscillator circuit? Okay, the Calpe oscillator is a type of electronic oscillator that use an inductor and capacitor to create an LC oscillator circuit. Edwin Calpe, an American scientist, designed the Calpe oscillator in 1918. It is a harmonic oscillator that is similar to a sinusoidal LC oscillator and has a wide range of application. The turn circuit in a Calpe oscillator is made up of two capacitors connected in series and inductor connected in parallel to the series combination. The value of the capacitor and inductor in the turn circuit affect the frequency of the oscillation. Okay, for the frequency, Fr equal 1 per 2 pi square root of LCT. Second, total capacitance C1 multiply by C2 per C1 divide plus C2. Third, L1 represent the self-inductance of the coil. Third, feedback fraction equal C1 per C2%.
Questions B. Referring to figure 1, discuss the output voltage calculated by the MATLAB simulating software. First, build a Colpitts oscillator circuits as shown in figure 1. Run the simulation to get the output voltage. You must select the output check box before entering a name for the output variable. Simulating saves the output to the MATLAB workspace at the base sample rate of the model if we set the format parameter to a value other than dataset. The additional parameters area includes parameters for specifying other characteristics of the saved data. To specify an interval for logging, use the logging intervals parameter. To log output data to the simulation data inspector, select dataset format. To log fixed point data, set the format parameter to dataset. If you set the format parameter to a value other than dataset, simulating logs fixed point data as double. If you use a format other than dataset, you can convert the logged data to dataset format. Converting the data to a dataset makes it easier to post-process with other logged data. For the active variant condition, Simulink creates a dataset object with the logged data. For inactive variant conditions, Simulink creates MATLAB time series with 0 samples. Do not use a variable name that is the same as a Simulink simulation output object, function name, or property name.
For the question C, how do you determine the oscillation frequency for this Colpitts oscillator? The calculation of oscillation frequency for the Colpitts oscillator, we use the value of capacitor and inductor in the tank circuit. The formula frequency is Fr equals to 1 over 2 pi square root LCT and Ct equals to C1 times C2 over C1 plus C2 is the total capacitance in the tank circuit. Firstly, we use C over C equals to C1 times C2 over C1 plus C2, and we put the input inside, so we get C equals to 21.82 nanofarad. Next, we use the formula for the frequency, which is F equals to 1 over 2 pi square root LC. Now we put the input, which is 1 over 2 pi square root 10 milli times 21.82 nanofarad. Now we calculate it, and we got 10.8 kilohertz.
Question D. The first step is we build a Colpitts oscillator circuit as shown in figure 1D. Next, in the circuit, we use 150 nanofarad and 240 nanofarad for the capacitor and 10 millihenry for the inductor. For the step 3, we calculate the resonant frequency using the total capacitance formula. Next, we find the output voltage in the circuit. We change the scope out to the display, then run the simulation. Then after we simulating the circuit, we find the waveform for the resonant frequency. And the last step is to get the appropriate waveform. We use and put the ruler to the waveform for the 1 VPP frequency. For the discussion, in this Colpitts circuit, we have acknowledged that the Colpitts oscillator consists of a parallel LC resonator tank circuit whose feedback is achieved by way of a capacitor divider. Next, the Colpitts circuit, like other LC oscillator, consists of a gain device with its output connected to its input in a feedback loop containing a parallel LC circuit, which function as a bandpass filter to set the frequency of oscillation. The amplifier will have differing input and output impedance, and this need to be coupled into the LC circuit without overly damping it. We also discuss some of the advantages in Colpitts oscillators, which are that the Colpitts oscillator can generate sinusoidal signal of very high frequency. Furthermore, the frequency can be changed by using both variable capacitors. This is because the capacitor provide a low reactance patch for the high frequency signal, and thus the output signal in the high frequency domain will be more sinusoidal.
Okay, in conclusion, we were able to identify the problem solving by using the various of simulations to find the final answers. Throughout this assignment, we were now capable of calculating output voltage, frequency like manually. We also learned to use the MATLAB application where we can draw circuits using Simulink and simulate graph based on the low and high frequency, especially of Colpitts circuit. Lastly, we were able to follow the various methods to finish our project successfully and also work as a team during this pandemic. Thank you.